Let's solve a geometry problem that leads to a system of nonlinear equations. So let's find the intersection points of the graphs of these two things. So what do the graphs of these look like? Well, the second one is a line. That one's not too bad to come up with a graph for. So 1, 2, 3, 4, 5. So there's the y-intercept, and then minus a half, so slope of minus a half, so something like this. This second equation, you might remember how to come up with a decent graph for rational equations, right? X equals minus 2, x equals minus 2 is a vertical asymptote because it zeroes out the denominator. So this will have a vertical asymptote at minus 2, and it'll have a 0 at x equals 1. So that's here. And also, it will have a horizontal asymptote at 1 as well, like that. So this is going to look something like, I guess maybe we should find the y-intercept as well. When you plug in x equals 0, you get minus a half. So that's like this. Oh, no, this way. Okay. So from this very rough sketch, you can see that we probably should expect two solutions. So intersection points, that's here, and it looks like there's going to be another one over here somewhere. Okay. So why does this give us a system of equations? Well, this intersection point, if we call it xy, then since it's on the graph of this first equation, that means it should satisfy this first equation. So we're looking for x comma y that satisfy our first equation, y equals x minus 1 over x plus 2. And since this point is also on the line, it should satisfy the second equation, y equals minus 1/2 x plus 5. So we're looking for a single pair of points. I mean, in fact, we'll find two, but we're looking for a pair of numbers that simultaneously satisfies both equations. But that's exactly what a solution to a system is. So we are looking for a solution to a system of equations. So with that in mind, let's solve the system of equations. Probably what seems nicest is maybe since the second equation, the line is already solved for y, we can just take our expression for y and plug it into the first equation. So minus 1/2 x plus 5 equals x minus 1 over x plus 2. I don't really like having this 1/2 here, so why don't we multiply both sides by 2? Sure, couldn't hurt. So minus x plus 10 equals, and then when we multiply the right-hand side by 2, we have to decide where to put it. Let's distribute it into the numerator. So 2x minus 2 over x plus 2. Now let's multiply both sides by x plus 2 just to get the x's out of the denominator. Okay, so on the right-hand side, 2x minus 2. On the left-hand side, we're going to have to multiply all this stuff out. So this is going to give us, let's see, minus x squared, and then minus 2x plus 10x, so plus 8x, and then plus 20. Now this equation has become quadratic, so we know how to solve this now. Move everything to one side. 0 equals x squared, so then minus 8x plus 2x, that's minus 6x. Minus 20, minus another 2, minus 22. All right. This isn't going to factor, I don't think. Right? The only factors of, at least not using integers, the factors of 22 are 2 and 11, so we're not going to get a 6 out of that. So we're going to have to use the quadratic formula. So we get 6 plus or minus square root 36 plus, let's see, 4 times 22, 88 over 2. So this is 6 plus or minus square root of 110, 24, 124 over 2. 124 is definitely divisible by 4, but that's it. So that's the only square factor. So this is 6 plus or minus 2 root 31 over 2. So this is 3 plus or minus 2 root 31, or sorry, 3 plus or minus root 31. So those are our y values, sorry, our x values. Notice that we found two x values, which is what we thought should happen, right? We found these two x values. Now for each of these x values, we can find the corresponding y value just by using this equation for the line. So y equals minus 1/2 x plus 5. So for the first one, we get y equals minus 1/2 x is 3 plus root 31 plus 5. So let's see, 5 is 10 halves, so minus 3 plus 10, 7 plus root 31 over 2. So this gives us the point 3 plus root 31 for our x coordinate, and for our y coordinate 7 plus root 31 over 2. Okay. And for our second y value, so now we're going to use the negative here, so minus 1/2. Did I forget to square something? No. Oh, I see what happened. This numerator was just seeming too big, and the problem is I didn't distribute the minus sign to there. So this should be a minus, so this should be a minus. Okay, now this seems right. Our picture suggested that for the larger x value, the y value shouldn't be very big. And I was concerned because this is the positive x value, but we're getting I got a y value that was way too big. So 7 minus root 31 is actually not that big, especially after you divide it by 2. So this is looking more plausible now. Okay, so now for the other one, so minus 1/2 times the other x value is 3 minus root 31 plus 5. So let me be more careful here. Distribute the minus sign, so minus 3 plus root 31 over 2 plus 5. So this is 7 plus root 31 over 2. Okay. So for this smaller x value, we got a larger y value, and that looks right on the picture, right? For this larger x value, we get a bigger y value here. So that seems right. So this solution is 3 minus root 31, comma 7 plus root 31 over 2. Okay, so we got these two solutions to this equation, and those correspond to these two intersection points of these two graphs.